still the 2014 SOL. Let me turn the volume up a little bit. The 2014 SOL starting with number 16. Okay, so the coordinate values of the vertices of triangle KLM are integers. Which set of coordinate pairs could represent the vertices of a triangle congruent to KLM? Well, first of all, let's start. How tall is LM? 1, 2, 1, 2, 3. 3 units tall. What's the base of KLM? 1, 2, 3, 4. And we know that since we use the straight lines, this is a right triangle. So our hypotenuse is going to be 3 squared plus 4 squared equals c squared. So 9 plus 16 equals c squared. 25 equals c squared. C equals 5. So this is going to be 5. And that's just an excellent thing to remember as we're doing these. So what I'm going to do is I'm going to plot the points, and then I'll probably just end up erasing them so our picture doesn't get too tacky. All right, and remember, you have graph paper you can do this on. So I'm going to do my first set of points in green. Okay, 0, 0. 3, 4. And 0, 5. Well, I've got my 5. But the question is going to be, is this going to be my hypotenuse? Because remember, it has to be congruent, so that would have to be my hypotenuse. So we would have to have a right angle here. Well, the slope is to negative 2, 3. Down here, 1, 2, 3, 1, 2. So that's not going to work because they're not going to be parallel. This is definitely 5. Did I do that right? 3, 4. No, it should be up here. Sorry about that. But either way, that does not change. That does not change in here at all. Okay, now let me ask you a question. This is 5, but do we have our 3 and our 4? This goes diagonally through 3 points, through 3 units. Would that be congruent as going straight through 3 units? Is that the same as this line right here? Oops, let me change that to red. Are these two lines going to be the same? No. That would be the hypotenuse, and if we form the rest of the triangle, it would definitely be longer than 3. So that's not going to work. Let's look at the second one. Okay, 0, 0. So A is not going to work. So let's go 0, 0. Negative 5, 0. And 0, 4. Well, this is 4, and that's 5. That's definitely not a 3, so that is way too big. So that's not going to work. Okay, let's look at the third one. Negative 1, 1. Negative 4, 5. And then negative 1, 5. Well, let's see. 1, 2, 3. There's 3. 1, 2, 3, 4. There's 4. So then my hypotenuse is going to be, because that's a right triangle again, 3, 4. It's got to be 5. Because that's a Pythagorean triple, 3, 4, 5. So your answer is C. Okay? And I'll apologize for getting so wordy in some of these, but I just want to make sure you understand exactly what I'm trying to say. All right. Number 17. All right. Click on the correct answers. Okay, this question is pretty tricky unless you read the whole thing. Okay, so in this similarity statement right here, does it say, given the two triangles, select two relationships, just two, that would prove triangle ABC. So A is going to be congruent to Q because it's congruent, similar to QRS. B is congruent to R. And then my blank ones by the side angle side similarity theorem. Now guys, remember when it's side angle side, it's going to be two sides and the included angle. Let me write this up here. Side angle side, two sides, and the included angle. Alright, so let's go through here and mark out anything that is not correct. Angle A is congruent to Q. Check. And I'm not going to mark them because I just want to get rid of, eliminate what definitely doesn't work. C is congruent to S. That works. Well, this isn't helping any at all. B is congruent to Q. Ooh, 2 slashes, 1 slash. That is definitely not working. Okay, so we got our angles figured out. AQ or CS would have to be in the included angles. So if we look at C, C is the included angle of BC and AC. BC is going to be proportional to 2 hooks to nothing RS. AC is proportional to 1 hook to nothing QS. Let's look. Does any of this match? There's BC over RS. No. So I need AC over QS. That's not working. AB over Q. No. Let's not mark that out because that might work for something else. Because we just don't have QR down there at all. AB and QR. Nope. AC and QS. And BC and QR. Well, that's definitely not going to work. Okay. So this is not going to be our included angle. So let's look at A and Q. What is A the included angle on? What two sides form A? BC and AC. So I'm going to set up my proportion BC and AC. BC is going to be proportional to, really, why did you write it backwards? It should say AC and AB, not BC, that should say AB. Okay, I apologize. AB is 1 hook to 2 hooks, 1 to 2 is QR. AC is 1 to nothing, 1 to nothing is QS. Do we have this over here anywhere? AB over QR, that works. AC over Q, nope, that's not going to work. See, I did mark it out earlier, but I want you to see why that it's not working. I need you to check all angles. And then we have AB over QR and AC over Q. Well, that works. So your two answers should have been this one and this one right here. Okay, let me highlight them for you. There you go. All right, number 18. I saw this problem done in so many different ways. And what shocked me is, really, it was a way that I had never looked at this picture. Diagonals of a square measure 14 centimeters. Well, I'm going to draw you guys a good square because I want you to see exactly what's going on. So my diagonals, remember opposite corner to opposite corner, right here to here, and here to here. They each measure 14. Well, one thing about it, when they intersect, what happens at that point of intersection? I'm hoping you say center in the square or square in the center. That means we're going to have 4 right angles. And if each diagonal is 14, what would each part of that diagonal be? Because they bisect each other, each part would be 7. Okay? then the question is, which is the length of the side of a square? Okay, so let's just look at one part. Let's just look at this triangle. We want to know what that is up there. I'm just going to kind of white out down here. Liquid paper. I love this stuff. Absolutely love it. All right, so what we could do now is, since we have two sides of a right triangle, made that a little bold for you. Since we have two sides of a right triangle, we can do the Pythagorean theorem to find the third side. So let's do it. A squared plus b squared equals c squared. 7 squared plus 7 squared equals x squared. 49 plus 49 equals x squared. 98 equals x squared. X ends up being 7 square roots of 2. So you should have got me. Is there another way you could have done this? Absolutely. I'll set it up, but I'm not going to complete the whole thing. We have our square back up here. Our diagonal is 14. We have a right triangle here. And what do you know about the sides of a square? Well, equal. So ignoring half this triangle, you could have done x squared plus x squared equals 14 squared. You would have got the exact same answer. Okay, that's the greatest thing about math, is there's normally more than one way to get this solution. All right, number 19. Now we have a congruent figure, and notice that they're switching these back and forth on you. They're going from similar to congruent, back to similar, back to congruent. You've got to read this. So angle M is congruent to angle P. Angle N is congruent to angle R, and then our two blank ones. All right, so let's find X. So that means MN going from 1 slash to 2 slashes is going to be congruent to PR. So 3x minus 9 equals 24. Add 9, we have 3x equals 33. X equals 11. Now we need to find y. We have this y right here, 1.5y, 2 slashes, is congruent to this right here. Where we have t is congruent to that one. Either way, t is congruent to, just set them equal to one another. So 1.5y equals 41.4. And divide both sides by 1.5. And you're going to get y is equal to 27.6. So x is 11, y is 27.6. Okay, there's number 19. Now on to number 20. Okay, based on the given information, which figure contains a pair of similar, and remember there's only 3 ways to prove similar triangles: angle, angle, side, angle, side, and side, side, side similarity. Those are your only 3 methods. Okay, so number 20, based on the given information, well, we have D is congruent to C, and we've got a bow tie, so we also have vertical angles. Are these 2 triangles similar? And how are they similar? You got it, angle, angle similarity. Okay. C, the only thing we know about is the angle and the side. D, we don't know anything about except those 2 given angles. And B, once again, just the 2 angles and a shared side. So that's going to be all for now. Please return for 21 on. Thank you.